All right, so we're going to do just a quick review of factoring. I know this is a review unit, so it's a review of a review. But just to quickly review the three key things here in this unit, we talked about finding the greatest common factor, factoring by grouping, and we talked about the special case factoring. So first of all, let's talk about greatest common factor. So first things first, when we look at a big polynomial like this, is I'm going to always look for a greatest common factor, whether I'm factoring by grouping or whatever. If there's a common factor that I can take out from the very beginning, I should do that. Okay? So looking at this, I've got a polynomial, it's a trinomial, right? And I'm going to look for a greatest common factor. So looking at these, I mean, it looks like 5 would go into all of these, right? And it looks like I can take out a p. So let's try taking out a 5 and a p, and let's see what we get left here. So if I take out 5 and a p, I'm going to be left with, that would be 10, right? 5 times 10 is 50. And I'd be losing one of those p's, so p to the third. And then take out a 5, it would be 5, so plus 5. And then I take out one of the p's, so p to the second. And then I take out a 5, and that would be 8, so minus 8. And that's it, so the p is gone. So looking at that, there's nothing else I can do there, right? And this isn't a quadratic, so I can't necessarily factor it anymore. So that's as far as I can go. That's just the greatest common factor problem. Okay, let's try another one. So let's look at this one. So I've got, let's see here. So I've got 3, looks like goes in everything. So I'm going to start out by taking a 3. There's not a k in everything, so I can't take out a k. So I'm going to take out a 3 to start with. Okay? So that's going to leave me with 4k to the third. And then minus k to the second. And then I'm still going to have, let's see, 120 divided by 3 is 40, so plus 40k, and then it would become minus 10 there. Okay. Now this does look like it does look like a quadratic, so I can factor this by grouping. So basically, I need 4 terms to factor by grouping, right? Or at least those middle term that I can split into 2, which you could not do with this one. So I'm going to factor this by grouping. So I still have this 3 in front. It's still going to stay there. 3 stays in front. And then this first one looks like I can take out a k squared. And that would leave me with 4k minus 1. And again, I have to make sure that I get the same binomial in each of these, or I can't factor it. Okay. So then we're going to try this one. I'm going to take out a 10, looks like. So I'd have a plus 10 times 4k minus 1. And I got the same binomial there. So again, I can factor that out in front. So I'd have 3 times 4k minus 1. And then I put what's left, k squared plus 10. And that would be my factored form. Okay. Last one we're going to do is a special case. So again, special cases, I'm looking to see if the number in front is a perfect square, and the last number is a perfect square. So this one, the number in front is 1. 1 is a perfect square. Last number is 9. 9 is a perfect square. Squares down to 3. It has this middle term, so that tells me it's going to be the 1 binomial squared. And basically, I take the square root of c, and I take the square root of the a, m squared, so that would just be m. And then I apply the sign of the middle term, so m minus 3 squared would be my answer. And that's it. That's factoring.